Jumping into the last learning target of this section, note that we have a p plus 2 now on the left-hand side of this equation. I still need to square in order to get rid of the radical, but when I do, I'm squaring that entire side of the equation, the p plus 2. Keep in mind, squaring has meaning. When I am squaring something, that means to multiply it by itself. So if you take a look at the learning target for this section, we need to be able to solve radical equations that involve the FOIL process. Because squaring a binomial, multiplying two numbers by two numbers, that's a FOIL problem. So just like factoring started to come back in the previous lesson, FOIL is going to come back in this one. So at this point, if you notice that you're getting behind on the numbers, feel free to pause it or slow the video down. Absolutely raise a hand early if you notice that you don't know where a certain number came from, where a certain calculation is from. Let me know what supports you need in order to get through this section successfully. These are going to be more labor intensive than the previous section. So FOIL, again, is an acronym. It's just here to help us organize our work. The F stands for first. So P is the first term in the left binomial. P is also the first term in the right binomial. So multiplying a P times a P gives me a P squared. The outside terms are P and 2. P times 2 is going to be 2P. My inside terms will be the same. P times the 2 is going to also be 2P. And then we get the last terms, 2 times 2. 2 times 2 is 4. So FOIL is just there to help us organize our work. When multiplying two terms by two terms, we get 4 terms. We don't want to forget about the right side. There's still a 3P and a 60 there. Keep in mind the radical's gone. The whole reason that we squared in the first place was to get rid of that radical. So there's quite a bit going on. Let's clean it up. 2P plus 2P in the middle. Well, if I have 2 apples and you give me 2 more apples, that's 4 apples. I also have the 4 from FOIL left over. And I still have the 3P plus 60 on the right. This is quadratic. So it's very similar to the previous examples in that we can try factoring. If you're really feeling anxious, you can do quadratic formula. If you like to do too much, you could do complete the square. I'm going to stick with factoring, at least for this example, because it is the fastest method. In order to factor, we need a 0 on this right-hand side. So let's subtract 3P from both sides. And while we're at it, we'll get rid of this 60. Goodbye. So we have P squared. 4 take away 3 will be 1. And 4 take away 60 will be a negative 54. So we want to factor again. Now we're looking for two numbers that multiply to negative 54. And if you caught my typo, you're amazing. This should be a plus P. Very nice. We want two numbers that multiply to negative 54 and add to 1. Multiply to negative 54 and add to 1. And those two numbers will be 8 and negative 7. So what this is telling us is that our quadratic has two factors, P plus 8 and P minus 7. These factors are distinct, meaning they're different from one another. So we're going to get two different solutions. We're going to get P equals negative 8, and we're going to get P equals 7. Now, we know that one of these might work, both of these might work, maybe neither of them work. But in order to do that, we need to do a bit of substitution and double check. It's important to note that when I go to substitute back in, this part's probably helpful to do by calculator, substituting those values for P into that radicand, that 3 times P plus 60. But we're not going to get back just P like we did in the previous examples. we're going to be looking for p plus 2. Going to be looking for p plus 2. So let's start with the one that I already know works, 7. Jumping over to our calculator here, let's go ahead and substitute that in. So we are going to do 3 times 7 plus 60. Again, 7 is what we found algebraically, so this is a solution that we would like to work. But when I hit enter on my calculator, I'm not expecting to get a 7 back. I'm expecting to get p plus 2. In other words, a 9, because 7 plus 2 is 9. I did get it, so we know the 7 works. On the other hand, if I go to substitute in the negative 8, negative 8. When I go to substitute in the negative 8, I get back a 6. Now, negative 8 plus 2 is a negative 6, but not positive 6. So I did not get back p plus 2. I did not get back the value that I expected. So we want to be careful when we're substituting in on these FOIL problems, because we're not going to get back exactly what we substitute in. There'll be some kind of manipulation, plus 2, minus 3, so on and so forth. So we did not get back what we expected. This is an extraneous solution, this negative 8. So if you have questions on the extraneous solution, on the FOIL, on the factoring, anything at all, please let me know. These are more challenging problems than the ones we looked at in the past. If you look through this one example and you go, okay, I think I got this, feel free to go ahead and attempt a Math Excel problem. I'm going to do all 4 of these examples as separate videos. You don't have to watch all 4 if you feel that 1 or 2 examples is enough. However, if you recognize that this will be a very difficult section for you, it is helpful to have all 4 examples to go off of, especially since examples 3 and 4 kick things up just a little bit. In addition, everything I've done so far I solved by factoring. I do want to do one example with quadratic formula. On the off chance you decide you'd rather do quadratic formula than factoring, I do want that to be an option available to you. So make a choice with your pace, with what you're comfortable doing. Feel free to carry on to the next video, or maybe try a Math Excel problem, or possibly throw up your hand and say, hey, I need help with blank. Just let me know what you need, and I'm happy to provide.